Hello and welcome to Easy Robot. My name is Victoria Bennett, and today we are going to be hearing from Dennis Kambeitz, CEO of Easy Robot, the most engaging robotic education platform. I probably gave the secret of today's discussion away in that line. To meet the needs for robotic literacy and mastery. If you have any questions, for those of you who've joined us, hello, David. Thank you for saying hello. You've already found the chat. If you've got any questions, just pop them into the chat and we will address them during today's session. For those of you who have joined us through Facebook, I will be toggling between the two. You'll see me sort of look over there. And that's just because I'm going to check if you have any questions too. So it doesn't matter if you're with us on live webinar or if you're with us through Facebook, we'll make sure your questions get asked before the end of the session. So first off, I'm going to introduce Dennis. Dennis is called upon globally to speak about educational robotics. Prior to becoming the CEO, he was the leading reseller for Easy Robot. So he truly understands the market and the reseller model from both sides. Can I ask the attendees to add into the chat what you hope to get out of this session? Brilliant. So last week, you clearly articulated the opportunity in educational robotics. If anybody missed it, it is on YouTube. You can go and have a look. It's on the Facebook too. And if you're signed up for the emails, I hope you are, you should also see it there. And the educational robotics market is currently $1 billion, and it's expected to reach $3 billion by 2028. That's a compound growth rate of between 15 and 27%, depending on whose numbers you look at, which is a huge growth rate. So Dennis, the market is big, it's growing rapidly. Why is Easy Robots the best place to capture more than your share?
So there's a couple different reasons. I guess the quick elevator pitch would be that Easy Robot is incredibly powerful, versatile, and easy to use. Now, the benefit of that is it makes it great for, university students. Our advanced users are making things like life-sized humanoid robots, drink dispensing droids, submarine robots, snow shoveling robots, real-world applications. But at the same time, the platform is so easy to use that we have children as young as 10 years old programming science fiction qualities into their robots, like speech recognition, vision tracking. They can learn AI using Microsoft's cognitive services with the platform and stuff. So it's an incredible platform of super easy to use and also incredibly powerful. And that appeals to the broadest range of students across the broadest range of ages. And then, one of the interesting things as well is within educational robotics, it really kind of breaks down into robots, like you've got Dash, Q, the Now robot, or platforms. You have Lego, Vex. And the interesting thing is the robots tend to be more engaging initially because they're cute, they're more approachable. The platforms tend to provide more enduring engagement because then children can build the robots of their dreams. They can bring their own inspiration to the robots. The interesting thing about the Easy Robot platform is it looks like a robot, but it's actually a platform. And so initially, students start working with it in the robot form. So they have rapid success. It's very engaging. They talk to the robot, it responds. We'll show some of these things later, but super engaging up front. But then as the kids start to get more knowledge, then they can build things like life-sized humanoids. So we can take students all the way from zero knowledge up to being, world-class roboticists within the Easy Robot system.
I mean, that sounds incredible to have all that flexibility through the platform. And, as you say, I mean, what's in front of you is what engages them. But actually, it's getting that initial hook and then keeping them interested the whole way and learning as they go. And we've talked before about, it's not that everybody needs to be able to code a robot, but everyone needs to have robotic literacy. So there needs to be, everybody needs to be engaged. And then, a subset need to sort of reach for the stars.
Yeah, exactly. So, when we've talked in the past, we've used the word robotics literacy. I equate that to computer literacy. So, the interesting thing is within education today, a lot of people, forward-looking principals or teachers might say, I'm reading about robotics and AI. We should probably have an option for the kids that are interested in this. And that's good thinking, but really the best way to think about this in the right way is to understand that robotics and AI within the workplace right now as we speak are making the same transition that computers did, right? Where it's becoming kind of integrated into all industries. And because of that, if you understand these technologies, you're going to be advantaged in all industries. And, I talked about the power and engagement, but just talking about what's actually happening in schools today, the way robotics is being taught, because it's mostly being taught like an engineering program, which appeals only to the most engineering-minded students, right? So you get the kids that are interested in robotics, capital R robotics, but you don't get the kids that need this literacy. So in high schools today, and I have verified these stats with 20,000 educators, so these are solid. In high schools today, the number of students interested in learning robotics averages 3% of boys and 0.3% of girls. So to put some kind of meat on those numbers, in a school of 2,000 students, you're talking about 1,000 boys, 1,000 girls. So 30 boys and 3 girls will be learning robotics. 1,967 won't be getting this education. And when you understand the changes that are coming, that level of overall student engagement is really a crisis. At the middle school level, people are doing a little bit better. 5 to 15% seems to be where the average is, depending on what products are used, how it's being taught. But now you mentioned at the start that I was a reseller for 6 years, but I was also running after school programs, summer camps. Schools were bringing me in to do residencies and stuff. So I've actually demonstrated and taught robotics to probably 20,000 kids at this point. And so, from inner city Los Angeles to New Jersey down to Florida, obviously significantly in Canada, New Zealand, Australia, Dubai, the UK. So across the entire globe, using the humanoid and the strategies that we use. Sorry, I got a frog there. At the high school level, we'll average 25 to 45% of students, boys and girls. So now imagine we can go from 3 girls out of 1,000 to 300 in a day or two. And the strategies that we've built up over the past decade are entirely replicatable. So the educators that are interested in getting more of their kids interested in this can use our strategies, and it will work for them as well. Right? The highest success level we had was actually a school down in Australia where we went in, and it was an all-girls school, and I was working with a class of 9th graders. We actually got 75% of those girls wanting to learn robotics. Wow. And when I walked in, I could tell that, you walk into the classroom and they're sitting there and they're all like this, and it's like, hey, who wants to learn robotics? Nobody, right? But then over the span of 1 hour, we went from virtually no engagement up to 75% of kids wanting to learn this. Wow. And we understand the changes that are coming. That's the kind of engagement we need. At the middle school level, we're doing significantly better. Even we will average 90% of kids wanting to learn robotics, right? That is a solution for preparing our kids for what's coming. So when we talk about Easy Robot and the share of the market or the benefit that we can bring to the education space, you were talking about growth that is going to average about 20%. Easy Robot's growth will be dramatically higher because really the I don't want to call it the battleground, but the what's needed is that we need all of our kids to get this literacy, but the way robotics is being taught doesn't always hit all of the kids. In fact, it predominantly doesn't.
So what I'm hearing from you is, the purchaser. So that's the schools, the school divisions, the school boards, educational authorities, etc. The reason that they choose you, as an Easy Robot, not just you personally, but the reason that they do that is because they know that this is a necessity and they know that they're going to get better engagement. And I've also heard, you know, from you and from users that your platform is easier to use, more expandable, and more cost effective. So you really hit every single requirement that your core purchasers are looking for.
Yeah, and just really quickly, and we're here to talk mostly about fun today, but the pricing is really important, because when we start, robotics is not super inexpensive the way it's being taught. Like, the cost per student is quite high, but when educators, implement robotics the way we recommend using this platform and stuff, you can use this platform multiple times a day to teach different students and stuff. So if you amortize the cost over a 5-year period, it gets down to as little as $7 per student to get robotics literacy and AI literacy. To imagine, to prepare our kids for the future, that's what the cost is. And so it's, when you look at the pricing from that perspective, it's not a lot. But one of the challenges is, if we're going to go from 3 girls out of 1,000 and 30 boys out of 1,000, and we're go from 33 students to 600 in a high school learning this technology, it has to be cost effective, right?
And ultimately, we need to get to 2,000 students learning.
Yeah.
I mean, that's got to be the goal. But I mean, just even getting it from 30, which is the baseline where it is today, or the highest baseline, to 600 is a huge leap forward.
Yeah, well, it's for overall, we're talking about a factor of 10 to 20 in terms of the number of kids that are interested in learning this. And for girls, it's even higher than that. To go from 3 girls to 300 girls is like, that's a 100-fold increase. Right?
And I have to say, I like the gender equality, because that's something that's so many people battle across the STEM world, is ensuring you get equal engagement. And I know this is far bigger than STEM, but even just looking at through that lens, to have that gender equality is great. So I'm going to ask you a question.
Yeah.
What is it that makes Easy Robot, and I can see JD there, what makes it so much more engaging than the competition?
Okay, so there's a real quick summary of how we get that high level of engagement. There's really 3 things that people need, and this is true of teachers as well, because teachers are also generally not enthused about teaching robotics if that's not their background, right? A principal that wants to bring this into their school, they probably don't have robotics teachers, and so it's like, okay, who wants to teach robotics? And that initially is a hard push until you do the same process. And so there's 3 things that everybody needs. They need relevance. Why should I care about robotics? If most kids, if the enrollment is 3% or 0.3%, most kids think robotics is gross. So let's just, right? We have to give them a reason why this is important to them. Okay, but if that's all we give them, that's not going to be enough. The second thing they need is inspiration. They need to look at this and go, hey, this looks like I'd actually have fun, right? And when we're teaching engineering or robotics like an engineering course, then it's not that much fun. If the lesson is make a robot follow a line, to what end? Most people aren't intrinsically interested in doing that. The engineering-minded kids love it, but the kids that are not engineering-minded, who actually need this literacy more because their jobs are going to be more impacted in the future, they're just not interested in that. So we have to make it intrinsically inspiring to them. So that's the second thing. And the third thing is confidence. And so when we do presentations in schools, we've got this whole system worked out where we can give people all 3 of those things in a really big way within an hour. But from just a visual perspective, the robots are really, really powerful. This is JD. You can control these robots with a computer, Android phone, iPhone, tablets, Xbox 360 controller, Wii remote, virtual reality glasses. So you put the glasses on, you see what the robot sees. You move your head, the robot will move its head.
Oh, cool. Even I'm engaged by that one.
Well, it's amazing, and it brings up so many learning opportunities and so many cross-curricular learning opportunities, right? So that's a whole other aspect of it. But here's my favorite way to control JD. JD, show me how strong you are. Try that one. Oh, there we go. Just took him a second to respond because my computer's also running the webinar here for me. Now, you can imagine in a classroom, like I'll talk for you know, 5 minutes or 10 minutes about the future and why robotics is important and why everybody needs to learn it. And then I'll tell people I can keep talking for the next hour, or I can show you what the robot can do. And everybody wants to see the robot. So I say, JD, show me how strong you are. And now the energy in the room just goes like this. It goes up really high. And the kids start craning their neck around everybody. You hear a lot of whoa and stuff like that. So now the kids are starting to get excited. And we start to see that Dennis maybe wasn't as engaging as he thought he was at the beginning of the presentation. But everybody loves the robot.
You've lost out to a robot.
I know who the star is, Victoria. Okay, so then I'll say to the robot, JD, what else can you do? Oh, 1 second. We got a false positive there, so just give me 1 second. Those happen from time to time. I was just talking too fast. I'll give it a second just to reset the voice here. JD, what else can you do? And now usually when the robot does the headstand, all of the kids start saying, can the robot do this? Can the robot do that? And this is awesome because the kids are now thinking what they would like the robot to do. So my response will be the robot can do those things, but you would have to program them. I haven't. But to show you how easy it is, and this kind of shows another little bit of engagement here, I'll show you something that was programmed by an 8-year-old girl. And this is not a savant programmer. This is just an average 8-year-old girl that learned how to use the robot. JD, can you sing Happy Birthday?
Happy birthday to you. Happy birthday to you. Happy birthday, dear human. Happy birthday to you. And many more.
So that's the girl's voice coming out of the robot, right? So it's super engaging again, right? So there's so many things that you can do with this platform because of the power that you just can't do with other robotics platforms. So we've got the student's voice coming out of the robot. All of the robots have cameras built in, so they can recognize glyphs, QR codes, color, object, motion, right? Faces, and faces are the most interesting objects for students, right?
So what you would say then is, because they can actually see themselves doing stuff, that's what makes it engaging. It's not just fun, cool things that they can do, which, you know, but it's also the fact that they can see progress. You know, that, I mean, something like that, to be able to code it, to sing, do a bit of dancing, you must get a real sense of achievement as a child, because you might think that this is a strange use of words, an alien thing.
Yeah.
And yet you can actually make something happen in the classroom.
So imagine a situation where, let's say you're in 9th grade, sake of argument, and you're not taking computer science because you think coding is gross. You're not taking robotics because you think robotics is gross. You think you don't have the skills needed to do those things. So you feel like you're not as smart maybe as the kids that can do those things. There's a lot of different kinds of intelligence. It's not that's not an accurate reflection of intelligence, but for many students, that's how they would judge themselves, right? I can't do that. I can't do that. So you've been telling yourselves for several years that you can't do it. And this really speaks to that third part, the confidence thing that I was talking about. So when I'm doing my presentations in school, we talk about the relevance. I show them the robot doing a couple things. We get the inspiration up. Everybody's like, hey, that robot's pretty cool. They just saw some magic. It responded to my voice. Then I get the students up to volunteer and program the robot. And with a class of students, and I do basically the same presentation for 4th graders as I do for high school kids, as I do for university students. But in about 45 minutes, 10-year-olds who've never seen this platform can program this robot to wave, to talk while waving. Then they'll record their voice and have it come out of the robot, the same as when it was singing Happy Birthday. Then they will program a new name for the robot and program in a speech recognition phrase. The student will talk to the robot responds to the student's voice, which is incredible. Like, could you imagine programming that if you're, 10 years old? Or if you're in grade 9 and, I mean, like, it's all the same. It's like learning a new language. We all start at, bonjour, or we all start at the start. Anyways, they'll also program the robot to recognize a color and track the color. So the robot will be moving its head, following the color around. The last thing we do is we have the students program the robot to recognize another student and greet that student by name. Now, they've programmed all of that in 45 minutes. Those are crazy advanced things. And at the end of it, in truth, they don't really know what they've done, most of them, but they know they can. And what I'll do is I'll have the software projected on a screen behind me. And so then the students will be, every student can see it. So the first student gets the robot to wave. Takes 3 minutes. Dead simple. So I'll say to everybody else, who could have done this? Put up your hand if you could have done this. And all the students will put their hand up. And this is great because now these students, like if you're in ninth grade again, we'll take our ninth grade student, you've been telling yourself you can't do that. And now you just told yourself, well, I could do that. But that's not real robotics. That's just making the robot wait. Right? And then the robot talked. Who could do that? Everybody. The robot, you put your voice in there. You spoke to the robot. You programmed speech recognition. Who could do it? And all the way through, all the kids are putting their hand up. So then I'll say to them, okay, so you all could program all of the things that we've seen here. And they will all say yes. So I'll say, perfect. Then I'll show them a video of a life-sized humanoid robot. And the robot is talking with the lady and it's interacting. And then I'll say, okay, you all said you could do this. Who could, who could program this life-sized humanoid robot? Nobody thinks they can. And that's a really interesting thing. And this is when we talk about building that confidence up and we talk about the advantage Easy Robot has. Now think about this. Everybody has programmed this robot, which is incredibly powerful, to do all of these advanced features, and they still think they can't do this. If they're working with one of the other platforms that are out there, there's no way they think those skills are jumping to the real world. They're looking at those other platforms largely being toys. So like, okay, I could program a toy. That doesn't mean I can do anything real, right? So now we've got the same skill gap or confidence gap happening here. And then I'll let them know that that life-sized humanoid robot uses the exact same hardware and software as this robot. The commands to program it are identical. Let's look at what it's doing. It's moving servos. Did you program your robot to move servos? Yes, you did. Y'all could do that. That robot is.
We know what a servos is. Let's actually get down to basics of that.
The little motors that move the robot, right? So, but they're like, okay, I could program the movement of that big robot. Then the big robot's talking. Did you program your robot to talk? Yes, you did. So you could do that. That big robot's listening. Did you program your robot to listen to your voice and respond? Yes, you did. You all could have done that. You've all already told me and shown me in the first 45 minutes that you could do 75% of what this life-sized humanoid robot is doing today, right now, the first 45 minutes of your robotics education. The confidence explosion that happens at that point is incredible, right? Imagine what happens if a 5th grade student knows that they could program something like this. How does that change their educational career? How does it change the courses they want to take in middle school or in high school or university, or the careers they think they might go into, right? This is the big thing for us. We are not just teaching coding and teaching robotics, and we teach them incredibly well. We are changing the way these students perceive themselves. It totally redefines their confidence, and it leads to better behaviors. Bullying goes away, grades go up across the board, attendance goes up. It's wow. Like, and the number of testimonials that we get like that, where people are telling us things like, you've changed the culture of our school. Everybody's buzzing about robotics, and coding. Now imagine, I talked about what if one student learns this? What if all your 5th graders learn this? And then, like, know that they can do this. And then, by the time they get out of high school, they've all done life-sized humanoid robots and stuff. What does that do for the reputation of the school? And then now imagine if a city does it. What does it do for that city? And when we talk about the changes coming to the workplace and to society that robotics and AI will bring, in case anybody hasn't seen it real quick, it's 20 to 47. The forecasts say 20 to 47% job loss or job elimination due to the technology. We're talking globally hundreds of millions of jobs, hundreds of millions of new jobs coming. If everybody in your city can do this, those hundreds of millions of new jobs are coming to your city. The job loss comes everywhere. The new opportunity only comes to the places where we have the highest level of technical, intellectual infrastructure. So it's incredibly important, again, that we get this mass engagement and we don't look at robotics as being an option that some kids need to get. That would be like saying that not everybody needs to get computer literacy. And this isn't the webinar to do this in, but I can, if people look at the previous webinar, they're going to understand that all of their kids need this literacy to be competitive in the workplace. Mm-hmm. And the kids that don't get this literacy are going to be tangibly disadvantaged. So to me, it's all about engagement. And once you've got the engagement, you want the high quality learning as well. This platform maximizes both.
And I remember you saying about being on is it a week-long course in one school? Oh, yeah. And you thought you'd been given, the A-star students. I don't want to steal your thunder, but to me, it's probably one of the most powerful stories that I've heard you talk about.
Okay, so yeah, I was asked to come and teach a week-long robotics class. It's called Experiential Learning Week, and so the students would learn nothing but robotics for a week. They said, "Would you be interested in coming and teaching this?" And I thought, I clarified, I'm like, the students will get nothing from 8:30 in the morning till 2:30 or 3:30 or 3 o'clock when they go home. It'll be all robotics all day long for 5 days. They said yes. I'm like, that sounds awesome. Let's do it, right? So I jumped in, and I had 15 boys from grade 7 to grade 12, 0 girls, because of course they said, who want to learn robotics? And all the girls said, no, thank you. But the interesting thing is we were in their library, that's where I was teaching this, and that's where the photocopier is for the students. So every girl that walked in during that week stopped and watched for 5 to 10 minutes as the students were programming the robots. And I said, would you like to, I'd walk over, I'd say, would you like to learn, robotics and coding and like that? And they're like, yeah, 100% of them, which I know that's what always happens. But the really, really cool thing from this program was at the end of the second day, I kind of took the supervising teacher aside and I said, like, I'm blown away by your kids. It's been nothing but robotics for 14 hours of class time, and they're still laser focused, right? And I said, I'm stunned. And what the teacher said back was just so awesome. He said, you don't even know the half of it. These are the kids that are failing or are nearly failing. They don't bother showing up to class. If they come to class, they tell the teacher where to go and walk out. Those are the kids you have here. And I didn't tell you that before you came because I was afraid you wouldn't show up. And I was so grateful that he hadn't told me, because I walked into that class with no preconceived notion. But the achievement level was very high. The engagement level was off the charts. I thought they had given me their grade A students, and they thought they had given me their challenging students. And that's just an example of some of the benefit that you can have when you've got tactile, hands-on learning.
And I can see for educators, if you have this cohort, and every school has it, where you can't actually connect with a student, or you're struggling, or whatever's going on, if you can connect to them through robotics and then layer on the other subjects, this could be the hook to bring them in. But I mean, it just speaks volumes that the level of engagement that you could achieve.
Well, and this is one of the things that makes robotics such an incredible STEM product, is there's math in there. Like when you're moving servos, that's all angles. There's physics in there. There's, you've got the electricity, you've got levers and leverage and gears. And so there's so much, there's cross-curricular learning that can be done with the robots once you achieve a base level of understanding. And it's interesting because we talk to educators sometimes where we've recently started working with the Amman Baccalaureate School in Jordan. And, one of the very first things they said was, how can we teach math with this? And I'm like, and I love that enthusiasm, but I'm like, first you have to get literacy, not just for the students, but also for the teachers. And this is an important thing that we have to understand as we try to navigate and make our education more technical in a cross-curricular way, which is really what the ideal scenario is. You have to have a platform that is dead simple for the teachers to learn, because they're already oversubscribed, right? If you're telling your math teachers, now you need to learn how to do programming, there's no way, right? So the interface has to be simple. And if you can do that, and if you can get those math teachers to be able to program robots and stuff in a couple or 3 hours, okay, you can get that. You're not getting a 40 or a 60-hour lift from the educator to try to get these extra skills. You can get a few hours. Mm-hmm. And with this platform, a few hours is enough to be able to use it to do other things and to be able to make it cross-curricular. And we've trained hundreds of teachers, the vast majority of whom had zero robotics or coding experience beforehand. I would say probably it's 95% of the teachers that we're teaching to teach robotics and coding haven't taught those subject areas. We don't have formal training in those areas. But we've got a great solution. We've got a self-directed curriculum, so the teacher doesn't have to be a master or stuff. Like we've tried to build a comprehensive solution so that every school can implement this.
Mm-hmm. I'm actually going to open up to the floor for some questions because I can see Diana's question just slots so neatly into this. So thank you, Diana. She's wanting more information about using with elementary students. So I think you've given a broad brushstroke, but I think, let's do a deeper dive in for Diana.
Okay, and I saw in the waiting list of people to get in. Now, Diana her school is doing exceptional things, right? And so they've actually built one of these robots, and they've got some of their students working with it, and younger students. So when I look at robotics for elementary, I guess the first thing to know is engagement with elementary students is tangibly easier because they are predominantly interested in everything. They haven't had years of their internal voice telling them, you can't do this, you can't do this, right? So when we work with elementary students with these robots, we're typically hitting around 98% enrollment and engagement. So we know that they're excited, but the truth is that at that age, they love lots of different products, right? And, like just because they love the learning aspect. So what I would say to that is within elementary, one of the challenges is the teachers don't have a high level of knowledge to be able to feel like they can teach, high level robotics. But the kids are excited about learning things like robotics. And therefore, like if you're using a platform and stuff, the kids being able to put the robots together builds an extra competency and a level of confidence in the design thinking type, and ability to influence your surrounding area. So that's awesome. And if we can get teach robotics that way to elementary school children, that's an ideal scenario. Within our platform, we have the ability to do programming in Scratch and Blockly, or it's Robo Scratch and Blockly. But and so with really young kids, we'll use Robo Scratch, and it's interesting because we'll use the hexapod because it has 6 legs, right? This guy's pretty easy to knock over because you try to make him stand on one leg, the balance gets a little bit soft, very durable. But with elementary aged students or younger elementary or middle elementary, you're probably wanting to use something like a hexapod because it's a more stable platform. But one of my favorite stories was we were teaching an after school program with second graders, and a couple of the students programmed the robot, the humanoid spider, to tuck himself into the smallest possible shape, right? And then they took it and they put it in the box. They say hexapod, go to sleep, and it would tuck itself into a small shape. And they put it in the box, and then they thought this was awesome, and I thought it was hilarious. They said, hexapod, where are you? And you hear from inside the box, I'm in the box. It's dark in here. And then they programmed the robot to stand up, and so the robot lifted the top off of the box, right? And so when we talk about, about a great way to teach it, we want to make the teaching about the inspiration for the children. Now, we didn't say to them, here's something to do. That was kind of free time, right? And so we always give the kids some tasks to do, right? If you learn how to make the robot wave, great. Now you know how to do movement. What do you want the robot to do, right? And in doing that, you're learning angles, and you learn really quickly with the humanoid that the right side is different from the left side. It's 180 degrees out. So if this circle is going to be at a 135 degree angle, then the supplementary angle is 45 degrees. I could add up to 180, and you start to understand those concepts intrinsically. 90 degrees, that's straight out, right? So getting the students to work with this at an elementary age is excellent. And we were working with somebody who had a double doctorate in education, it was math and learning environment. And what she was doing is she was using this robot to help students build strong visual spatial skills. And there's evidence out there that says that, it's kind of like math is the foundation of, logical thinking and stuff. And then below that, you've got visual spatial skills as the foundation of math. If you can visualize, your math skills are higher and everything else goes easy. And so because of the way the software is laid out, and because students are working with a physical robot, they're transposing two-dimensional image and numbers, angles, into a three-dimensional world. And you get really good at starting to visualize how to manipulate things in the three-dimensional world and what that's going to look like. When you do that, things like math just become easier. And in this way, if you can do that in the elementary grades, then what you're going to end up with is students that are all of a sudden having better math grades. They're having better success across the board. And this is why I say robotics is so great. And if we understand, what's coming in the future, how robotics and AI are going to transform all industries and be integrated and the like, getting this education at a young age and getting this confidence is tremendously, tremendously valuable. Mm-hmm. And it also, the kids that are taking this in high school have learned it in middle school. The kids that are taking it in middle school have learned it in elementary. But I do want to, and this is not really, what the question was, but I do want to talk a little bit though about something that I do hear a lot, and it's a phenomenon that exists in education where, from the school's perspective, it's logical that you would say we're going to start with our elementary age students. We're going to build a robotics program, and then we're going to build it up over the years because we're just learning at the school level as well. And that is a perfectly logical plan from the school's perspective. The challenge is the changes in the workplace are coming so quickly that the students that need this desperately are the ones in middle school and high school. And so if you do this, really, we're not giving the skills needed for those students to be successful. And so what we suggest is you need to bring in education kind of from the side to all grade levels. And the interesting thing is the fourth graders, in year one, the fourth graders and the 12th graders might be learning more or less the same thing. It's literacy, right? It doesn't matter if you're
the pace they're learning is that may be different.
Right, yes, a 12th grade student is going to learn it faster than a fourth grader, but they both, again, if you're learning French, you start at bonjour. Doesn't matter how old you are, right? And so you can bring in a program from the side and offer it to multiple grades if it's a good program. And ours is, like, our curriculum is written to a 7th grade reading level, but it's being used as low as 4th grade and it's being used as high as university, right? Our introduction curriculum. So you bring it in from the side, and in year one, everybody can have access to that same introductory curriculum. Then in year two, only the youngest students are getting introduction and the students that you missed in the previous year, right? And in this way, you're building up a really solid infrastructure of technical education, but you haven't had to start at the start. And that's an important thing for educators to understand. You're not implementing at the high school level advanced robotics because the students don't have basic robotics. Mm-hmm. So you're starting with basic robotics for everybody, and then you're building up. So that's kind of a side answer to the whole elementary school question.
Yeah. So I mean, if it's being taught all the way through, then it will be building year on year. But as you say, it needs to come in sideways because we've got a bit of catching up to do.
Yeah. Next
question. Who are your main competitors and why are you better? Good one.
Okay, I'll run through some of the more popular products that are out there. There's Lego and Vex that are at the middle and high school level and university level. First robotics competitions, which are a side thing, but very technical engineering minded, like where people are building real world robots to compete in competitions like shooting a ball through a hoop or things along that line. And then within the robot category, we see things like Dash and Q that are programmable robots. But in terms, and then there's some other products that I think are actually quite effective for lower elementary as well, depending on what you want to do with the robots. If you have a robot is going to be mostly a prop for teaching coding. Okay, and that offers a level of education, but it doesn't allow inspiration and design thinking. And that's where we want to get our kids to, right? And for that reason, I like the platforms better, but I sure like the engagement that robots bring. And now in terms of power, so a lot of our competitors don't have anywhere close to the processing power and features, right? Their controllers will have 6 or 8 ports. Ours has 24 digital ports, 8 analog, UART, 3 I2C, and a camera, right? So we've got more than 30 connections. This allows you to build powerful things. You can use real-world sensors on this, right? Infrared, ultrasonic, accelerometer, gyroscope, CO2, oxygen sensors, light sensors, LiDAR, the same technology that they use in self-driving cars, you can use with this platform, right? To build your own self-driving car, right? So in terms of the power, we definitely have an advantage there. In terms of the ease of use, there's an advantage there as well, right? And with something like Lego or Vex, where you have a whole bunch of pieces, and let's be honest, a lot of kids have Lego at home, right? Sometimes those Lego pieces accidentally get lost in the classroom.
Big kids as well.
So, it's whereas our products are, they're a larger form factor, and they don't tend to go home as much as something like Lego might, right? Mm-hmm. So if you've got a Lego kit and you lose 5 or 10 pieces on your next project, that might be a real problem, right? So we teach robotics initially through robots. You build the robot, it takes about a half hour to build. When you know what you're doing, it's a 7-minute build. It's super fast and easy. I mean, you saw it's like this. Okay, slide, 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 arms built, right? So it doesn't take a long time. Plug it in, plug it in, plug it in. But the biggest thing by far is the engagement, right? When I talk about, what 20,000 teachers have told me they have for levels of engagement, it's 3% of boys and 0.3% of girls at the high school level. That's not with this platform or whatever. That's across the board. That's what it averages out to. And some schools will do slightly better. Some schools will be up to 60 kids out of 2,000. Awesome. You're doing twice as good as the average, but that's still not anywhere close to good enough. And so the biggest advantage is we can get all of the kids, or the largest percentage of kids interested in learning, and then we can give those kids this, a really truly high-end level education for the ones that want it. The ones that aren't going to become roboticists or programmers, just get that literacy, right? And a great example of why that literacy is needed is, within the education space. The teachers that are getting hired today are significantly technology teachers, robotics, coding, 3D printing, cybersecurity. If you have those skills on your resume, you are in much higher demand, right? And but teaching is not a high-tech career for the most part. Although now what we're finding is a lot of schools are trying to convert their non-high-tech teachers into high-tech teachers because of the shortage, right? So if you have these skills as a teacher, your advantage. And it's this way for business managers, retail store managers. Again, I don't want to get into that whole, big topic, but that's the reality that we live in today. So the engagement is by far the most important thing, and we are magnitudes more engaging than the competitors' products.
So you've got the robot that's really engaging, but the platform that's incredibly powerful and scalable. That you can literally, so you can sort of start at the beginning and take it all the way up. So you can do the literacy, and you've got that scalability to do, as you say, even up to university with the same kit.
Yeah, and so this is another one of our products. It's not on my table. It doesn't look nearly as exciting for most people. Some people would look at that and go, "That's incredible. I could build my own robot, and it would be super awesome." But if we start teaching robotics with this kit, even with our incredible, easy to use, platform, it's still more intimidating, because now you're telling kids you have to learn robotics, coding, design thinking. You're putting an extra layer of learning on the children for step one that really shouldn't be there. What should be there is literacy first, then get into design thinking. So we use this product for level 2 of our education.
Yeah.
I mean, people, can do things like this in level 3 and level 4 and stuff. So it's, the other interesting thing is we're teaching coding with Python and with JavaScript. And so kids are getting real coding experience. And again, knowing what's coming in the workforce, the world is being reinvented by robotics and AI as we speak. When we're looking to do optimal practice for computer science education, right? Okay, first on the computers, we're going to start with literacy. But if we're going to start to teach the kids coding, we should be teaching coding through the lens of robotics. Because if you can code the physical world, you can code your computer, right? Coding on a computer is good. Coding the physical world is excellent. It gives you twice as many opportunities, because we're starting to see, obviously, smart cars, right? Cars that can drive themselves, smart fridges, smart toasters, smart light bulbs, smart shoes, right? Everything is getting reinvented. And if you understand how to code the physical world, you're tangibly advantaged.
And it's that relevance that probably makes it even more fun. I mean, just what you did there was, was fun, but then to make it relevant and layer on a sense of achievement, I get it. I get why, you really are the most engaging platform that's out there. So
just, can I just jump in real quick? There's, if you say to students who wants to learn variables and programming if-else statements and stuff like that, I mean, that's gross, right? Nobody wants to learn that. But if I say, hey, Victoria, let's get this robot to recognize my face, and you're sitting there and it greets me by name, what's the next thing you want the robot to do? Recognize your face. Now, wouldn't it be cool if the robot could differentiate between us, and it could know that I'm Dennis and you're Victoria, and it could ask me about my favorite hockey team, and it could ask you about your favorite soccer team. I'm just saying, because you're from the UK. But that is very engaging for the students. Nobody wants to learn variables and if-else statements in programming, or at least the majority of kids don't. But all kids want to make the robot recognize their face and greet them by name and be able to differentiate. So when the outcome is cool to the student and exciting to the student, they're happy to learn the process, right? They've got an emotional attachment to the outcome because it's a physical manifestation, right? Because they're making something better and more interesting. And if we take that approach, it's way better. Like it's just stronger education. And a good example would be, if we're talking about STEAM, right? I used the word STEM earlier, but let's pull the arts into this. So, we've got some kids that are engineering centric and some kids that are art centric or, humanities centric. So how do we get a student that loves to do art interested in learning technology? Okay, here's a great example. How about you're going to design a merry-go-round? So now we're thinking about, you're going to draw something or draw and color it, and then you're going to stick it around together so it can go in a circle, because that's what merry-go-rounds do. That's how you get the infinite loop there. And then, okay, so then you build your merry-go-round, and you could say, isn't this incredible? And everybody will be like, yeah, they'll be proud of what they've created. And your STEM-centric kids are not going to be as excited about the drawing the merry-go-round project, but your art kids are going to love the drawing the merry-go-round project. But they're both going to be excited about step 2, which is, wouldn't it be cool if this merry-go-round could actually go around in a circle? How can we make that happen? Okay, well, let's do this. Let's put a servo on there, right, with a platform. And now this can power the merry-go-round and make it go in a circle. Well, how does a servo work? Well, you're sending electricity and you're sending a signal. Now we can teach all kinds of technical education with our merry-go-round, and everybody's interested because the art kids want their cool art project to be more powerful and more cool. And the kids that are interested in the engineering, they didn't love the first part where they were drawing, but they love the part where they get to make it move. And then you can say, okay, let's have our merry-go-round play music. Let's add a speaker to it. Let's have our merry-go-round be voice activated. So we could say merry-go-round start or something along that line, and then it starts to go. And then we could add LED lights. So there's so many things that we can do. And if you're going to add LED lights, that adds some complexity, because if it's going around, then your wires are starting to go around. So it's like, how can there's so much engineering you can build into that merry-go-round. And all of the kids on the art side that are art-minded or humanities-minded aren't going to be excited about all of that technical learning. But if you make it important to them, if you build it around what matters to them, they're excited to learn it. And that's really what we need to do within our education if we want to get all of our kids this literacy. And that's what this platform allows to happen, because the easy stuff like making movement is incredibly easy. Mm-hmm. So kids that they don't need to learn how to be a Python coder, right? But we can still make things accessible and easy to them so they can get that literacy and get that base knowledge. And then later in their life, they can apply this if they want to be a teacher or a fashion designer or whatever career they want to go into.
I've got a great question come in. What does the future hold for Easy Robot?
I think the future is really exciting. So we did some numbers the other day, and I would say that thus far, we've probably transformed the lives of about 100,000 students around the world, right? Where kids that were not interested in robotics that are now super excited about it, right? So we've given those 100,000 kids a much brighter opportunity for a great future. And we're just getting started, right? So as a company, we are increasing the number of resellers we have globally, which allows us to reach more children simultaneously. We're training more teachers in different schools and school districts and countries, and that allows them to reach more kids, to multiply our efforts, right? So I think that Easy Robot, if I was to forecast forward 5 years or 10 years, I would say Easy Robot is in universities. We already are, but we're in a lot of universities, and we're not just in the engineering department of universities. We're in the teaching department, the medical department, right? Because this technology goes everywhere, right? And I see it being integrated heavily into the schools, because we can do things that other platforms just can't do right now, and other products just can't do. And it's, I love the hardware. The hardware team, the people that built the software, have made an absolutely incredible product. But I've been doing this for 10 years, so we also understand the needs of the educators, right? What, the curriculum needs, the classroom management needs, the hardware needs, the how do you speak to the teachers? How do you get the teachers on board, right? So we do things that are designed to create culture change in schools, and we help schools navigate that so that all of their teachers are excited about this new robotic technology that's coming into the classroom. And again, like when I talked about what happens if a whole school can build this, right? I see those situations happening already. And those schools are going to be tremendously advantaged. Those kids will be advantaged. And I see this kind of technology being democratized so everybody can get it. When we look at the inequity that exists in the world today, learning robotics and coding and AI is a huge, huge equalizer. And if we're talking about it costing $7 per student to get literacy, that's a pretty affordable price for pretty much everybody.
Yeah. And I think on that note, I've checked on Facebook. I hope we've addressed everyone's questions, but I think, it really speaks to you have not just the platform, but you are poised for incredible growth, and really to gain much larger than the market share of a very rapidly growing market. As many of you know, the Easy Robot campaign to raise capital to support that growth is currently on Equivesto and has already achieved over 116% of its goal. You can still invest, you haven't missed out, and you can also use your TFSA and RSP for investments over $2,500. So hop on to equivesto.com for full details, and make sure you have signed up to keep up to date on all the news from Easy Robot. Thank you so much, Dennis. Thank you, everybody, for attending. I think we've had some great insight as ever. And really appreciate your time today, everybody.
Thank you, everybody. Thanks, Victoria.
You're welcome.